RT is route target and RD is route distinguisher, so that you can distinguish route in multiple VRFs, I guess. I'm not sure about that. And there are two flavors of VRF. One is VRF Lite and the other one is, I think, with MPLS or BGP.
What is VRF Lite? Do you have idea about it? VRF Lite?
No, sir.
Anyone have idea about VRF Lite?
No, sir.
Yes, sir. Basically, VRF light calls when we are using BGP without MPLS. Am I
Dot
correct?
LS. Okay.
Sir, yes. If we are using MPLS and BGP combined, then we can call like MPBGP or complete VRF. I'm not sure I'm right or not, but I have read earlier like
Yeah,
so.
VRF Lite means VRF without MPLS. And another one is VRF with MPLS, that is MPLS VPN, also called, we called it MPLS
L3 VPN.
MPLS L3 VPN.
Yes.
Okay. So no worry, we'll see both types of VRF. Before discussing the types of VRF, what is VRF? VRF. Can anyone tell me the need of VRF? Why we need VRF? Because I had already told you the answer of this question in the BGP session, if you remember.
Yes, sir. Sir,
In the
basically VRF we use when in the provider edge router, there is multiple customers. So and the customers are using private IPs. So router need to understand which prefix we are getting from which customers. So that reason we need to VRF, and we divide the routing table into uh, multiple routing tables on the basis of RT and RD value
For an
at the
example,
PE.
here I have one router. Let's say R1, R1. And guys, there are two interfaces on the router. One is F0/0 and one is F0/1. F0/0 and F0/1. Here, let's say my IP address is 10.1.1.1/20. Can I configure same IP address on F0/1?
No, sir.
No, sir.
What will happen if I will assign same IP address on two
Sir,
interface of router?
router will give duplicate errors.
Overlapping or duplicate IP.
Duplicate
How
errors
router will get to know about duplicacy?
by the
Gracious
routing
R.
table, sir. Routing table.
By the routing table?
Yes,
Right,
sir.
you all know router maintain routing table, and by default both the interfaces are member of same routing table. By default there is only one routing table on the router, that is called global routing table, and both the interfaces are member of same routing table. So what will happen when I will configure 10.1.1.1 on F0/0? It is going to make one entry like this prefix is directly connected. It will also find the network ID. Network ID is going to be 10.1.1.0/24, and this prefix is directly connected on which interface? On F0/0 interface. Now if I am going to configure same IP address on F1/0, it is again going to make entry in the routing table, but same network is already there. So even we cannot configure any IP address from the same subnet on F1/0, even 10.1.1.2. Right, we cannot configure any IP address from the same subnet on router number, correct? And with the help of VRF, here what we can do, we can create multiple routing table, right? So the definition why we need VRF, what can be the answer of this question? Whenever we need to connect multiple customers to the same physical device, if I have multiple devices for multiple customers, then no issue, VRF is not required. But if I am going to connect two different customer or multiple customers, to same physical device, then there will be issue, because
Yes,
router maintaining only one routing table by default. So both the customers are going to part of same
same
routing
routing table.
table, right? Means here customer prefixes are not guys separated, right? The customer networks are injected in same routing table. We are not able to separate the prefixes of customer or separate the customer network, right? So here we need what? Something called segmentation. Segmentation means
Division.
division, dividing
Yeah,
something, right? Like if I will ask you VLAN, what is VLAN? So VLAN stands for virtual local area network, which is used to segment the network at layer 2,
correct.
which is used to divide divide large broadcast domain into multiple broadcast domain. So division. Here also we need to divide the routing table of router, right? We need here two routing table for two customer. If I have multiple customer, here we need separate multiple routing table for multiple customers. Then VRF comes in picture, right? And if I will talk you what is VRF, so what can be the definition of what is VRF? We can say it is nothing but one routing instance on router, instance of routing table, we can say instance of routing table, right? And each VRF has their, each VRF has its own routing table, right? So after the VRF, can I configure same IP address on two interface of router? Yes.
Yes.
For an example, on router number 1, now I have two VRF A and VRF B. This interface is a part of VRF A, this interface is a part of VRF B. First of all, you will create the VRF and then you will assign the interface in that VRF. And after that, whatever traffic will be received on that interface, that will be injected in the routing table based on that VRF, into the routing table based on that VRF. So right now, router 1 have two routing table, A and B. Here if I am going to configure IP on F0/0, 10.1.1.1, right, it is going to find network ID and then it will install it on F0/0. When I am going to configure IP on F0/1, now router 1 is going to make entry in another routing table, right? And we don't have any prefixes here for the same subnet. So very easily we can configure the same IP address over here. It is exactly similar like VLAN. VLAN performs segmentation at layer 2 and VRF performs segmentation at layer 3. In SD-WAN, also we have concept of VRF, but the name there is VPN. VPN is also
Yes.
one kind of
VRF
VRF only. Right? VPN stands for virtual private network.
network.
This is also one kind of virtual network or physical network. Okay. So where is the need of VRF? Generally, we are using VRF in the service provider network. Why? Because service provider is connecting guys multiple customer together, multiple customer networks together. Okay. Now, for an example, router 1, router 2. Let's say router 2 only. I am not talking about P router. Right? These two are provider is router R1 and R2. One minute. service provider is connecting two companies network. Between R1 and R2 we have lots of P router, we can have multiple paths. And guys, VRF, we can not only create VRF on router only, on multi-layer switch also it is going to be same. Either here we can have multi-layer switch or I can have router. On multi-layer switch, definitely on the P router we need so many interfaces. So I can prefer L3 switch here also. And now for an example, two customers are there. Customer A and let's say customer B. These two are side 1 of customer A and customer B, and here is the another side. Same example. Connected like this. Same provider router is going to connect two customer over here. R3, R4, 5. P provider is one I am saying, and this one I am saying customer A side 1, and is customer B. Here customer is and customer B. Here. Customer B side 2. So how we are going to differentiate the customer? With the help of VRF? Simply here I will create one VRF, VRF A, and in VRF A I am going to assign the interface which is connected with customer A, and here I will create another VRF, and I will assign the interface which is connected to customer B to the VRF. Now router need to share prefixes of customer A side 1 and customer B side 1 to router number 2. Router number 2. How many we have? How we can share it? How we can advertise two routing table from R1 to R2, guys? How I can advertise two routing table from R1 to R2? Definitely we need two link here. One link is going to carry traffic of VRF A and one link is going to carry traffic of VRF B. Definitely possible. Yes, possible. If here we have multi-layer switch instead of router 1, router 2, I can have, see, either it is multi-layer switch or router. If we have one link, then also we can forward traffic of VRF A and VRF B with the help of sub-interface. Let's say between router 1 and router 2, I have only one link. I have only one link which is F0/0. F0/0. But between router 1 and router 2, I need two link to forward the traffic. So I can do one thing here. I can divide this interface into sub-interface F0/0.10 and I will assign it in VRF A. And here F0/0 F0/0.20 and I will put it in VRF B. That is also possible. That is also possible, and here on router number 2 also we can do same thing. So now this interface and this interface both are member of guys same VRF, both can communicate, right? Can this interface communicate with this interface? No, both are in different VRF, right? And this interface can communicate with this interface. Both are in same VRF. correct? So now whatever prefixes I will advertise from this interface, maybe I have configured .1q on this interface for VLAN 10, VLAN 10, and here also I have similar configuration .10
Configuration.
for VRF A and F0/0.20 for VRF B. So whatever prefixes now router 2 is going to receive on this interface, it will forward, maybe it will forward from this interface because both are member of same routing table. Whatever prefixes router 2 will receive on this interface, it will forward from this interface, both are member of same VRF. Here also you have BGP, here also you have BGP, and here also you have BGP. So if router 2 is receiving some prefixes from their BGP neighbor, definitely it will advertise to other BGP neighbor if that neighbor is in same VRF. So in this case we can configure it in the same VRF. So here MPLS is not required. MPLS required here? Not required. Even if I am using two link here between router 1 router 2, MPLS is not required.
But sir, in BGP, we configured MPLS, right? To have a communication between site of same customer. We have enabled MPLS, right?
When it is required, brother? When we have
Sorry?
PE router. P on the PE router, routes is not available. Na? Here between router 1 and router 2, directly we are exchanging the route. Here there is no any router who don't have route. When customer side 1 user is going to forward traffic to P router, this P router will directly forward it to this P router.
So, okay. So suppose if we would have some service provider routers over here, sir, between R1 and R2, then MPLS would have been required, right?
Yes,
You mean to say? Okay.
here MPLS is required. So either we can use sub interface on layer 3 switch. Guys, here I have 3 customer A, customer B, and customer C. And between P1 to P2, I have only one link. So how I can configure the VRF? How we can exchange the route? A, B, C. Again, this is side 1, this is side 2. What we can do over here? We can configure this link as trunk link. And I can create one SVI here for VLAN 10. I will put that in VRF A. VLAN 20 interface, I will put that in VRF B, and VLAN B 30 VRF C. Trunk link can carry traffic of all the VLAN, right? So we can again exchange the routes over here. This is the basic need of VRF and how we can forward the route between the routers. If we have only one link between R1 and R2, no problem. If we have multi-layer switch here, no problem. If we have 2 link, that is also fine. So in all the case, you can implement the VRF. Correct? Another scenario. This is fine. Any question still here? It's subinterface.
And sir, I have seen that on P customer facing interface is also enabled. .1q is enabled on that, and multiple customers are attached to that interface, single interface.
Then here you have to use any another device, na brother? See, if this is my router and I need lots of interfaces, I can use one switch here and then I can connect all the customer.
I'm saying single interface. Single interface.
How single interface can connect to customer?
Sir, by dividing it into like, and it means by enabling .1q encapsulation and creating multiple VLANs or VRFs.
But how one port, see, with the help of sub interface, we are dividing one link. How you can connect one link to 2 customer?
So I have seen this in our network, BT network.
Is it possible?
So
you don't know about the device. Here they are using another device between customer and their provider edge router. It can be switch.
So, but on PE also we have excess of PE over here. Okay. So suppose if one interface, suppose F1/0, this interface name is F1/0 for VRF-A, you can see.
Router 1,
If you-
and here is one interface
Which
F1
is
slash F0 slash
going
0.
to, which is going to, yes, this is going to multiple customers, like .1Q,
How
F0/0,
it can,
.10,
how
.2.
this is this port, this inter one cable can connect multiple customer? That is my question. It can only connect one customer, na?
Physically, yes. Then they configuration wise it is possible, but you are saying that definitely there would be a switch which would be having further links to other
In that
customers,
case,
right?
you can.
Because मैंने देखा है sir, I've seen this.
ये तो होगा ही ना फिर.
Suppose F0/0 goes down na, we have a multiple outage in different customers which BT is maintaining.
Correct,
So we
correct.
call it a, suppose line card fails. So multiple outage we has been occurred into network just because of this particular interface got hang, or some line card of this interface got hang or faulty.
Correct.
So okay, so switch is there, which or some switch is only which is having multiple ports, right? Or there is any alternate device which can divide one single interface into multiple.
Yeah, many other devices. Even you can use hub as well.
Correct.
But definitely there will be some device here between C to P. And in this case, we can divide this physical interface into multiple sub-interfaces. So what I am saying, why I am teaching you this? Just I am trying to make you understand this, that we can not only put physical interface into the VRF. We can also put physical interface. We can also put sub-interface. We can also put tunnel interface. Tunnel is also one interface on the router. We can put any interface in the VRF.
So you explain something about the trunk ports. आप दोबारा repeat करते हैं क्या सर?
उस
ट्रंक पोर्ट्स के
स्विचिंग
बारे
में
में
आए
मैंने डिस्कस किया.
सर, वो आपने कहा था ना मल्टीपल विलेंस को अलाउ करता है
Yeah, there are two
स्विचिंग.
types of switch port. One is access port, another one is trunk port. Access port carry traffic of single VLAN, and trunk port can carry traffic of all the VLAN. Let me open NS3.
इन स्विचिंग वी विल लर्न.
Yeah, yeah.
अंजलि.
Generally, we are using VRF in the service provider network or in large enterprises company.
So sir, okay. सर आपने आर्बन में सब इंटरफेसेस बना रखे हैं, राइट? डायग्राम में.
Sub interface. So let me use one router here, router 2, 4, 5. Okay. Customer is side 1 or you can say the network of a large enterprise company. Here my subnet is 10.1.1.0/24. Here also my subnet is same 10.1.1.0/20. We can have it. Here I have subnet 20.1.1.0 and here my subnet. And between the routers, should I mention the prefixes, guys? Between the router?
हाँ sir.
सर
Prefixes
वही
यहाँ पे
12
लिखो.
आएगा 12
Here we have 12 subnet 12.1.1.0/24. Here we have 13.1.1.0/24 and 14, 25 and 26. Okay, let's configure the basic IP addresses first. On R1, config T, interface F0/0 no set command only. Interface F1/0 no set IP address 13.1.1.1.255.255.255.0 exit. Interface F1/1 no set and IP address 14.1.1.1.255.255.255. Right. Do so IP route. You can see both the interfaces are part of same routing table, but I want to separate these two customer, right? Let's create the VRF and then definition. This is command to create VRF definition, and after that you can give the name, any name to this VRF. Another option to create the VRF is IP VRF, but here you can see I have defined the IP command. That means this VRF is only for IPv4. VRF definition can work for IPv4 as well as for IPv6. If I am saying IP, guys, anywhere IP OSPF means IP version 4 OSPF. IP means IP version 4. So IP VRF and then again name of the VRF. So you can use any method to create the VRF. Let me create here two VRF. Name of this VRF is, for an example, A. And another VRF, IP VRF B. So how many VRF are there now? 2. So do so IP VRF is the verification command. Here you can see how many VRF are there? 2. Name A and B. Is RD value set here? Not. Till now we didn't talk about RD value. Is there any interfaces in VRF A? Interface? Nothing, null. In VRF B, there is no any interface. Right? This is first verification command. Do so IP route. This is command to check routing table. This command will show you the global routing table. If you want to check routing table of VRF A, here you can define the keyword VRF A. Right? You can see in the routing table I don't have any route. In VRF B also, you can see I don't have any route. Right? This is the routing table of VRF A and VRF B. Now once I will add this interface F1/0 in VRF A, it will inject this 30 subnet in VRF A routing table. interface f1/0, and to assign any interface in VRF, this is the command ipvrf forwarding. ipvrf forwarding and the name of VRF. So I want to put this interface in VRF A. What it's saying, guys? Interface fast Ethernet 1/0 IPv4 disable and address remove due to enabling VRF A. So router is putting this interface in a VRF now. Earlier, if you have configured any IP address, that IP address is removed. You have to configure the IP again, right? So again, I can say IP address 13.1.1 255.255.255.0. And now if you will check the routing table of VRF A, so IP route VRF, so IP route VRF, what it's saying?
Caps.
This VRF does not exist on the router, right? So capital, and you can see in the VRF A routing table we have 30 subnet, right? Once I will put f1/1 in VRF B interface IP VRF forwarding VRF B. Again IP is removed, IP address 14.1.1.1 255.255.255.0. So that's why before configuring the IP you should assign the interface in VRF. Okay, now so IP route VRF, okay, and VRF, clear. Now between router 1
So
and router 3,
can we see the global routing table, sir?
do so IP route. In the global routing table, guys, is there any interface?
No.
So in the global routing table, now you are not able to see any subnet here. Okay. Now let me configure R3 here. And before that, I can do it on router number 2 also. Config 3 IP VRF A exit IP VRF
Interface.
IP VRF B exit interface f1/0.
Sir, why we are creating B on this?
A B
Then why B on R2?
to separate the customer network.
Okay. Okay, R2. Okay, I think. Okay, got it.
Instead of B, you can create P also, Q also. Any VRF you can create over here. But if you will be using same VRF and you have lots of sites connected to service provider, it is going to help you, right? Later you will learn this. Nobody clear. So here also I
Same
have
name should be there.
same names.
On, okay.
This is not mandatory, right? We can inject route as well between the VRF. Right now you can see do so IP route VRF A. In VRF A we have 30 subnet, in VRF B we have 40 subnet. By default router is not going to inject routes between the VRF, but if you want you can inject it. Okay, so later we'll see that.
Means these VRF can communicate with each other as well.
Yes, two
Okay.
VRF can, means two customer can communicate with each other.
Each other. Yeah, VRF means customer only. Okay.
Customer A, I can inject customer A prefixes in customer B routing table as well. Actually, we are creating a separate routing table for the customer. Now here you can see on router number 2, I have VRF, but there is again no any interfaces. So let me put the interface. Interface f1/0 IP VRF A exit interface F, and we can do one thing. We
Forwarding.
can configure IP as well. IP VRF forwarding A and IP address. IP 25.1.1.255.255.255. Exit interface f1/1 IP VRF forwarding IP address 26.1.2.255.255.255. We have again similar output here. Do so IP route in the global routing table. I am not able to see any prefix. Do so IP route VRF A. In the VRF A routing table also, I don't have subnet. In VRF B, why I don't have subnet? Do so IP
Shut तो
interface
नहीं सर इंटरफेस
सिर्फ हाँ सट ही है.
शट ही है
Interfaces are down. So interface range F1/0 and F1/1. No.
नो शट
And then so IP VRF route VRF A. Done. 25 subnet, and in VRF B 26 subnet. Now between customer is to R1 PE, we can configure any routing protocol to receive this internal subnet. Let me configure R3 first. R3 and config T. Guys, do we need to create VRF over here?
No.
Is VRF required? Not required, right? Both interfaces are part of same company. VRF is not required here. Interface, we don't need to separate the routing table here. Right? First of all, okay, interface F0/0, no such, and IP address. What IP address? 13.1.1.1.255.255.255.0. Interface loopback 1 IP address 10.1.1.
13.3 आएगा सर
0/0 dot loop 13.3. And now I can configure any routing protocol here to send the prefixes. Let me use OSPF or EIGRP. Router EIGRP is number 10 and network 0.0.0. Network 0.0.0.0. Correct?
करेक्ट
So IP EIGRP topology. So in the topology table you can see I have installed both the subnet. But show IP EIGRP neighbor. Do I have neighborship? No. Guys, on router number 1, if I will enable EIGRP, router EIGRP is number 10, and here also I am going to the network 0.0.0 command. What will happen?
so it will enable the EIGRP on all the connecting
On
interfaces
all the, yeah,
It will
VRF.
only enable EIGRP on F0/0, which is the part of global routing table. Right? This way we cannot configure EIGRP for VRF.
VRF.
Right? So instead of configuring EIGRP globally, I am going to disable it first. No router EIGRP 10. Okay. And then router EIGRP yes number 10. Where is the option of VRF? Where is the command of VRF? Somewhere there is command of VRF. Let VRP brother 1 hour. Okay. So guys, how many of you know about the address family? What is address family?
Sir, I have seen the configurations.
Anyone have idea?
So like IPv4 and IPv6 address family, like in
IPv4 and IPv6 are what? These are two rooted protocol of network layer.
Yes, sir.
mm,
These are, guys, you know what? In IPv4 or in IPv6, what is the difference?
sir, IPv6 like 32-bit and IPv6 128-bit.
Okay, that is fine. Any other difference?
And
The
sir,
routing
BGP,
behavior is going to be, different.
yes,
In case of,
BGP work on IPv4, not IPv6.
it can work with IPv6 also. We can
Okay.
run in IPv6 network also. These are types of network. These are types of network. IPv4, IPv6, another types of network are there. And address family is used to enable routing for a particular type of network. By default, whenever you are configuring OSPF or EIGRP, those all configuration are only for IPv4. When you will configure EIGRP for IPv6, you will see the configuration is different. What I told you, if I am saying IP, it means IP version 4. I am talking about IP version 4. So this command router EIGRP ES number 10 and ES number here earlier I had run. Then here this command. This command is going to enable EIGRP for IPv4 address family. This command is going to enable EIGRP for IPv4 address family. IPv4 is also one address family. So here we will use address family to configure VRF, sorry, EIGRP for the VRF. Right? How? I will say address family over here, then I will select my network. If I will put question mark here, you can see I have only IPv4 option. On some devices you will get IPv6 also. Here we have only IPv4 family. Some devices you can have IPv6 family also. So let me select it. And then it is asking what? VRF. For which VRF you want to enable EIGRP. Just wait 1 minute.
Sir, first we have configure router EIGRP 10 and then address family, right? Guys, आप बता सकते हैं because I didn't see the screen. I was listening.
Yes, that's the correct. Yes.
Right.
Clear? Any question till here? So what is address family? If someone will ask you what is address family, what can you answer? What will be your answer? What is address family? Address family prefer network protocol, networking protocol. Right? It can be IPv4, it can be IPv6, it can be VPN v4. Later you will learn. Address family means types of network protocol and their associated IP addresses. In VPN v4, you are going to see the prefix will look like different from IPv4 prefixes or IPv6 prefixes. IPv4 prefix looks different from IPv6. VPN v4 looks different from IPv4 and IPv. Or we can say like group of address. Address family is group of address type. So with the help of address family, here we are going to enable EIGRP for VRF. Right? So here now I can say unicast and then VRF, and after that I can give the VRF name. So this command will enable VRF for. Sorry, this command will enable EIGRP for which VRF? A. Will it enable EIGRP on any interface? Will this command enable EIGRP on any interface? And one more thing guys, see, you know the EIGRP neighborship parameter is autonomous system number. Autonomous system number must be same. And here I have defined autonomous system number what? 10. This autonomous system number doesn't matter. Here even I can say 100 also, right? We are going to use the autonomous system number which should be same for the VRF. Here I can say autonomous system number and this should be only 10, right? If, because what I told you, this command router EIGRP S number 100 or 500 will enable EIGRP for IPv4 network type or network protocol. It will not enable EIGRP for VRFA. I want to form EIGRP neighborship between F like router 1 and router 3 in VRFA. So address family IPv4 unicast VRFA and then autonomous system number, and this autonomous system number should be same, and I think I have configured 10 only on router number 3. 10. This should be 10. Now will I have EIGRP neighborship between router 1 and router 3?
Sir, I have one question. So we need not mention router EIGRP, just directly mention address family. That's it.
Router EIGRP 500 address family IPv4 unicast VRF and then autonomous system number. That's it.
Sir, what is the use of unicast there?
Unicast, you know, there are three different types of traffic: unicast, multicast, and broadcast. So I have enabled for unicast. I have enabled EIGRP for VRFA, and which type of traffic? For unicast traffic. But guys, so IP EIGRP neighbor. Do I have any neighbor here? So IP EIGRP neighbor. No.
No.
And with the help of this command, I am checking EIGRP neighbor for IPv4, not for VRF, right? So instead of running this command, so IP EIGRP neighbor and then VRF. So EIGRP for VRFA and then this command. This command will be used here. Do I have neighborship? Reason is till now I have not enabled EIGRP on F1/0. In EIGRP, how we are enabling EIGRP on the interface through network command, right? So do I have use any network command on router number 1? No. Again, router EIGRP S number 100, and if I will run network 13.1.1.0, will it enable EIGRP on F1/0? Again, no. I have to run network command for VRF A only. So address family IPv4 unicast VRF A, and here I will run network command network 13.1.1.0. This command will enable EIGRP on F1/0. Right, and now if you will check, so IP EIGRP VRF A neighbor, soon we will have neighborship ping 13.1.1.3. Ping is not working. What is the issue? Number 3, so IP is brief. This is up, and so IP EIGRP is enabled on both interface R1. XO IP VRF. So F1/0 is in VRF A, that is fine. And so IP interface brief on F1/0 13.1 interface is up. There should be reachability. So IP route VRF A dot 1.1.0 is directly connected. Okay, fine. The ping should work 13.1.1. Why I am not able to ping, guys? Because I am pinging from
Version 4, I think.
global routing table,
Need to
right?
mention.
Yes. So here ping and then VRF A, and after that 13.1.1. Now ping is working, right? Now ping is working. And so IP EIGRP VRF A neighbor. Here I don't have neighbor. Then EIGRP. Oh my, here I am running EIGRPS number 500,
500.
and I have advertised network in 100.
100.
Right, so
Yes. This is
router EIGRP 100, router EIGRP 100, and router EIGRP 500, and address family IPv4 unicast VRF A, autonomous system number 10, and network 13.1.1.0. Now we will have EIGRP membership. So IP EIGRP VRF A and bug IP EIGRP VRF A. These are the troubleshooting command, verification command. So run section EIGRP EIGRP router 500 address last then work dot. Now we have neighborship. So IP EIGRP VRF A and neighbor. Who is neighbor? 13.3. And now in VRF A routing table, I am expecting 10 subnet also through EIGRP, but show IP route EIGRP. In this command, we cannot find it, right? So show IP route VRF A and then EIGRP. So you can see through EIGRP it is running 10 subnet. Okay, like this you can configure any protocol here, BGP, OSPF, EIGRP or RIP, but make sure you will enable the routing protocol for particular VRF.
Sir, if we have multiple customers on the connected to single physical router, then we have to create a unique VRF name for each customer, right, sir?
Right. Okay, now let me access R4 and let me configure R4, and here between let's say R1 and R4 I am going to use any other protocol. Interface F0/0 no set IP address 14.1.1.4 55255.255.0 to ping 14.1.1. This will this ping work, guys? Yes, definitely this ping will work. Ping is working. Then interface to back 1 IP address 10.1.1 255.255.255.0 exit router OSPF 1 router ID I am saying 4.4.4.4 and network I am saying 0.0.0.0 255.255.255.55 and area G. So IP OSPF interface brief. IPF interface brief. OSPF is enabled on both the now go to R1 and let me configure OSPF for VRF B. For which VRF? VRF B. Here command is going to be router OSPF process ID 1 and then VRF. For which VRF you want to enable OSPF? For VRF B. Clear? Then network 14.1.1.0 while karma 0.0.255 area ID 0.0 and now I am expecting OSPF neighborship and here you can see the neighborship. So IP OSPF for VRF. So IP OSPF neighbor VRF
VRF B neighbor. VRF B neighbor. Like EIGRP.
VRF B neighbor. So P the command. For now we can do one thing, we can check routing table. So IP route VRF. So guys, in VRF B routing table also you can see we have same subnet 10.1.1.0 and in VRF A routing table also we have same subnet.
Sir, on EIGRP, we have mentioned address family for IP version 4. But OSPF, there is, we didn't mention.
It will
So by default, it may.
automatically get to know about it. See, we have created VRF4, IPv4 only, so it will
IP.
sense from there.
Okay, okay. So if you want to mention for IPv6, we have to mention manually.
The configuration can be different in EIGRP or in OSPF. That command it can be different. In EIGRP, we change the network protocol with the help of address family command separately in OSPF. While enabling only, we are calling the VRF.
Yes.
Not available, guys. So if here should be VRF option. Command is not available particular router. Here you will get this command VRF, right? Maybe in the simulation command is not available. Okay, here you will define the VRF, then VRF name, and then neighbor. This is the command to check OSPF neighborship for particular VRF. Now in the same way, on router number 2, between router 2 and 5 and router 2 and 6, we will configure any protocol. Now we need to forward these prefixes to router number 2. So guys, the first thing is, if I want to send this 10 subnet on router number 2 in VRF A, then first thing is what? VRF A must be there on router number 2. Then only we can inject it, right? If A VRF is not available, then we can not advertise the prefix. So here we have already created the VRF A and VRF B is already there. This interface is a part of VRF A, this is part of VRF. Now what I am going to do here, I am going to create subinterface f0/0.1, let's say, and f0/0 dot. Here also f0/0.1, f0/0 dot 2, and we'll add it in which VRF? In VRF A. We'll add this interface in VRF B. And I am already running EIGRP for VRF A. So I will advertise this interface in EIGRP and this interface in OSPF. Automatically we will have neighborship here also between router 1 and router 2 we will have neighbor, right? And this can be the virtual link also, like your tunnel interface also. Let's say between router 1 router 2 there is ISP, and over ISP we have 2 VPN, 2 GRE tunnel, T1, T2, T1, T2. So I can again insert this interface in VRF A, this interface again in VRF A, and here we can advertise this tunnel 1 interface in EIGRP, tunnel 2 interface in OSPF. Then also we will have neighborship. Right? So link can be physical or it can be virtual. Right? When we will discuss the VPN, after that you can try it.
Can we use BGP here, sir, in R1 and R2?
Yes. Then you have to perform redistribution. Then you have to
Yes.
redistribute EIGRP into BGP and BGP into EIGRP.
Yes, sir.
So right now my f0/0 is a part of global routing table. Let me create the subinterface f0/0.1 and encapsulation protocol .1Q4 VLAN 1 for example, and here IP address. Before IP address, VRF, IP VRF forwarding A, and IP address here. Let's say now I need to submit here. Let's say 12.1.1.0 is there and 21.1.1.0 is there. Right, where I am going to run this subnet. Going to run this subnet between f0/0.1 to f0/0.1. 12.1.1. and 21.1.0 turn on f1 as f0/0.2, f0/0 So now I have two virtual link between R1 and R2. This virtual link can be over the physical subnet also, right? Same thing I told you, you can practice after learning GRE. So now here I am going to configure IP 12.1.1.1 and 255.255.255.0. Exit.
Sir, here why do we mention here dot one queue protocol here? Already we have mentioned VRF forwarding A on the sub interface.
So brother, how you can create the sub interface? Sub interface means what? Sub interface means what? If I am going to run guys command IP VRF forwarding be here and IP address 21.1.1.1 255.255.255.0. What it's saying? Configuring IP routing on LAN sub interfaces only allow if that sub interface is already configured as a part of IEEE.1Q.
Okay, sir. Okay.
Right? The interface, your sub interface
Yeah.
should first configure for either IEEE.1Q or IEEE 802.10 or ISL VLAN. Then only you can configure the IP on sub interface. Right? So first I am going to say encapsulation.1Q for VLAN 2 here, and after that IP address, same IP address. I'm done.
Yes.
Now do so IP VRF. Now you can see in VRF A I have two interfaces, in VRF B also I have two interfaces. So IP EIGRP VRF A and interfaces. EIGRP is only enabled on F1/0. Now we need to enable EIGRP on F0/0.1 also. So router EIGRP is number 500 and then address family IPv4 unicast VRF A, and here I am going to run network 12.1.1.0. So this command will enable EIGRP on F0/0.1. Now you can see EIGRP is enabled on 2. And OSPF is, so IP OSPF VRF. Okay, this command is not working here, no worry. But OSPF is guys here. In OSPF I am running, I think, network 0.0.0 or 12.1.1.0, sorry, 14.1.1.0. So run section OSPF
14.1.
14.1. Then I have to add one more network command. Okay, even if I will run 0.0.0.0 command, then also it will only advertise F1/1 and F0/0.2 because these are the two interfaces in VRF B only, right? So IP OSPF 1 VRF, IP OSPF VRF, router OSPF, sorry, router OSPF 1 for VRF B and network 21.1.0 and 0.0.5. Yeah. And now on router number 2 we can configure same thing. Router EIGRP for that sub interface 0.1 encapsulation.1 for VLAN 1 IP VRF forwarding A and IP address 12.1.1.5525525.0 exit, and then interface F0/0.2 encapsulation.1Q and IP VRF forwarding B IP address 1.1.1.2 55.255.0 exit. Router EIGRP is number 10. This EIGRP is autonomous system number, not matters. Address family IPv4 unicast for VRF A and autonomous system number 10, and network 12.1.1.0. Now we will have EIGRP neighborship here also between R1 and R2. Yes or no? and R1 will advertise prefixes to R2 now, but neighborship is down. Ping VRF A 12.1.1. Why ping is not working? Let's troubleshoot it. So IP interface brief. The interfaces are sub-interfaces are guys administratively down because your physical interface is down. So interface F0/0 no set. And now ping is working. Even we have EIGRP neighborship. So IP EIGRP, so VRF A and neighbor done. And so IP route VRF A. In VRF A routing table, you can see 10.1.1.0 network is coming through EIGRP. Got it? On which interface? On this interface. So if we are running any routing protocol now between router 2 and router 5, same EIGRP. So router 2 will advertise it to R5 also. So only we need to advertise one more network command here. Router EIGRP S number
10 we have used 10.
router EIGRP S number 10 address family IPv4 cast VRF A work 25.1.1. Then go to R5 and config T interface F0/0 set IP address 5.1.1.5 255.255.255. Exit router EIGRP S number 10 network 0.0.0. So IP EIGRP neighbor done, and so IP route EIGRP 10.1.1.0/24 is here. RD or RT, those things are not required over here. You can see in front of you. Now guys, can side 1 and side 2 of customer communicate? Yes, they can communicate. Here also we can create the loopback. Interface loopback 1 IP address 20.1.1.1 255.255.255.0 and go to router 1, check routing table. So IP route EIGRP. Soon 20 subnet will come here. Here then, so IP route EIGRP, so IP route VRF A EIGRP EIGRP IP route VRF A so 20 subnet is there. Now R2 should advertise it to R1. Let me check R1 routing table. So IP route VRF A EIGRP. Here also 20 submit is coming. Now R1 should advertise it to R3. Now let me take you to R3 and so IP route EIGRP. 20 subnet, right? Ping 20.1.1.1 source 10.1.1.1. Ping is working. These sites are able to communicate with each other. In the same way, between customer B site 1 and site 2 can also communicate. I need to configure R6 only. Config T interface F0/0 no set IP address 26.1.1.6 255.255.255. Face loopback 1 IP address 20.1.1.1 255.255.255.0. Exit router OSPF 1 and router OSPF 1 for VRF, not VRF here, for 0.0.0 0.0.0 255.255 and area Then go to R2 and let me enable OSPF on F1/1. Router OSPF 1 VRF 3 work 26.1. IP dot VRF 20 subnet is here. IP OSPF neighbor next start state. What happened? Neighbor chip is stuck. Now it is done. 20 subnet is here. So now 20 and 10 subnets are there in both routing table, right? On router number 1, if I will show you, so IP route VRF A, right? So 10 is there and 20 is there. In the VRF B routing table also we have same subnet 10 and 20 is not there, so 20 will also come. I think OSPF neighborship is not there between R2 and R1. Here we didn't enable 10 subnet IP dot RF 10. 10 is not there now, so we don't have OSPF neighborship over here. Router OSPF 1 VRF B work 1.1.1.0 area. Now so IP route VRF 10 20 sub also come, and both the customer sites are able to communicate. This is simplest way to configure VRF, and this VRF is called VRF Lite. Where we can configure it either over VPN, virtual private network, or right when we are running same subnet on the link between P to P, when we have single link, right? We are running same subnet on the link, like here you can see. On this interface and this interface, IP belongs to same subnet. On this interface and this interface, IP belongs to same subnet. Here we can have multiple router, doesn't matter, right? This is for in case of internet service provider, because our internet service provider public network only you are going to create, right? Or sometime you can have L2 VPN over here. L2 VPN is a service provided by service provider, right? So even let's say this is one P router, this is another P router, and between P there are so many routers, but service provider is going to provide you a direct link between this router to this router, right? They will ask you to create one virtual link over here, virtual interface over here, one virtual interface over here, and will allow you to configure same subnet here, same subnet on this link, and that is responsibility of service provider how they are going to make reachable, right? They will create L2 VPN here. L2 VPN means leased line. You might have heard about leased line. In this case also we can configure VRF. But guys, what about our scenario which we have discussed in the BGP? R1, R2, R3, R4, R5. This is P. This is another P. 1. We are not running same subnet. Here I have one loopback 1.1.1.1. Here I have one loopback 3.3.3. If we have BGP neighborship between 1.1.1 and 3.3.3, then how these routers will forward traffic?
MPLS.
Then MPLS, okay? And that is called MPLS L3, right? So tell me, should I implement this scenario today or tomorrow? Otherwise, here only we can modify it. In the same topology, we can modify. I can
Tomorrow,
help.
Monday, sir.
We'll see MPLS L3 VPN. Till then, you can practice VRF Lite here. Even you can add 2 physical link and we'll assign 1 port for VRFA, 1 port for VRFB, right? Both is going to be exactly same. Here you can use L3 switch also. If you have L3 switch in EVNG, then you can that as well.
Sir, I have one small doubt here. Between R1 or R2, if we have a multiple router means, then we have to enable IGP protocol between R1 and R2, right? Between all these routers. So that this VRF light can be activated. Okay, sir, if it is between R1 and R2, there is an ISP means through public IP address also, is it possible to configure this
Through public IP
IGP?
address, you will create VPN. Here are the ISP and ISP given with the public IP address over here 1.1.1.1. Here 2.2.2.1. So with the help of these two public
Okay.
IP address, both will be reachable. I will create one virtual network, and on that virtual network, I will configure, let's say, this subnet 10.1.1.0/20. So now you can see both the router are the same subnet. Here I can put this port in VRF, and after that we can configure VRF Lite. So that is ISP concern now, how they are going to make reachability between these two public IP address.
Yeah. Okay, sir. Okay.
Is wait guys one. Now in the VRF you only need to understand RT and RD. Otherwise you know the concept, you know the configuration. Even configuration is going to be exactly same. Only we have to understand what RD and, because guys, let's say on router number 1 I have one loopback 1.1.1.1, and on router number 2 I have one loopback 2.2. And if we have only one protocol between 1.1.1 and 2.2.2, we have only one protocol, one link, right? So which protocol I can run between 1.1.1 and 2.2.2? Can I configure OSPF here? The requirement of OSPF neighborship parameter is subnet should be same, subnet mask should be same, but here subnet is different. We can only configure BGP here, correct?
Yes.
yes.
Only BGP is the option. Can only configure BGP. Now through same routing protocol, we need to forward traffic of two different VRF, correct? Then there will be issue. How BGP can understand this 10.1.1.1 belongs to AVRF and this same subnet belongs to VVRF, belongs to different customer, right? So then we have RD value. RD value, which is going to differentiate the route of VRF. Simply what I will do on router number, just give me 10 minutes. I am explaining this point. After that, in the next class, we'll see the implementation. What I will do, guys, here I have already one VRF, VRF A, and VRF. Now I am going to run one more extra command for VRF A, like this command. Order 1 VRF IP VRF A, and here I am saying RD value 1:1 for an example. You want to see the range, 4 bits value, 1. Okay, let's say 1:1. And so IP VRF. Now here you can see I have defined the RD value, and so IP VRF A, and then detail command. What is the command? So here I have VRF A. RD value is 1:1. Interfaces, there are 2 interfaces in this particular VRF, and VRF put VPN or target. IP VRF VRF. Now you know what will happen here. Now my router 1, here for VRF A I have defined RD value 1:1. So whatever prefixes now router 1 is going to receive in VRF A, it will add this RD value with prefix. For an example, this 10.1.1.0/24. So 10.1.1.0/24 will become 1:1 here. After adding 1:1, your prefix will look like this 4//24 and 1:1. And this particular prefix is called VPN v4 prefix. VPN 4 that we'll discuss in the last class, and I will tell you more about RD and RT value also. RD is used to differentiate the prefixes, and RT is used to import and export the prefixes. Now router 1 is going to advertise this submit to router 2, and in the same way we have same network in VRF B also. And for VRF B, let's say I have defined RD value what? 2:. So here VPN v4 prefix is going to be 2:. Now you can see both the submits are different, right? So router 1 is going to advertise both submit to router number 2. Now how router 2 will get to know that which prefix I need to inject in VRF A and which prefix I need to inject in VRF, or which prefix I need to export in VRF A and which prefix I need to export in VRF. So to import or export prefixes of VRF, we have concept of RT value, right? RD and RT, these are 2 terms. No worry, notable. Yes, I will.
ನಾನು ಅವಳ ಜೀವಿತ ಪಾಕ
ಸರ್
ഒന്നും കൂടി തുള്ളിച്ചാടിട്ട് ഒന്നും കൂടി വീണോട് കയ്യിലിരിപ്പ് തന്നാവണേ
Hello, sir. There's some noise.
അനക്കെന്താ കോഴിമുട്ട
From
തിന്നാൻ
where
എന്താ
I am
കുഴപ്പം?
getting noise?
Sir Vishnu.
പ്രതികാരം ചെയ്യണടി.
Hello, sir. From the yesterday BGP states class, which you tried the last time, I have tried myself with this one. This access control list, it was working fine with the inbound direction only. Outbound direction only, it was not working.
Okay.
Even both routers. Then I have applied the inbound direction access control list. Then the state was it goes to idle. BGP state achieved, but why outbound direction it was not working.
Was working in both the direction, but maybe one device is using different port number. That's why BGP neighborship is coming. Let's say you have apply in indirection on router number 2 between router 1 and router 2, same topology.
Okay, sir.
Right.
Okay, sir.
So router 2 will block the traffic if destination port is 179.
Yes.
Right. So maybe router 1 is using that port number 179. Right.
Yes, sir. Correct.
So in the
But I have
outbound
changed
traffic
this.
only, the outbound traffic only port number will match, right? But this is not true. It should work in both the case,
Yes,
direction
correct.
and in out direction. Where was neighborship?
Even some, yeah,
Neighborship is stuck in which state?
idle state it was stuck because both router I have configured in direction.
Your ACL is not working then properly, na? It is filtering the route. That means.
Sir, ACL it was working. That's why the state was go to idle.
The state should be in connect or active, not idle.
After I removed one router in direction access control list, then automatically it was up.
Routers are not able to establish TCP connection, right? But route is available. Then neighborship should stuck in active state or in connect state. The idle state. The idle state router search routes for the neighbor IP address. If route is not available, then only neighbor. Enough. So I will come up with internal reachability. My case 1.1.1 and 2.2.2 will be able to ping each other. Then we'll see the VRF configuration and route exchange between P.
So within this service provider, you have mentioned within service provider we have to configure IGP, right, sir?
Correct.
To make reachability, yeah, between all the routers. Then
first we'll
yeah,
configure
then
any IGP protocol OSPF to make reachability between 1.1.1 and 2.2.
Oh.
सर मंडे IGP प्रोटोकॉल कॉन्फ़िगर करेंगे सर R1 और R2 के बीच में देन
क्या करेंगे?
सर मंडे जो आप बोल रहे थे ना रीचेबिलिटी ऑलरेडी रहेगी, कैन वी डू इट इन द क्लास इटसेल्फ?
हाँ, क्लास में भी कर सकते हैं। आप नहीं कर सकते हो यहाँ पे OSPF इनेबल?
कर सकते हैं सर।
टाइम ही जाएगा ना, वो तो बहुत आसान हो जाना चाहिए अब आपके लिए OSPF कॉन्फ़िगरेशन यहाँ। OSPF implementing OSPF here in the service provider network should be very easy for
It will
every
be in the same area, all the routers, all the
doesn't matter.
interfaces.
We can configure multiple area also, we can configure same area also. Not matter only OSPF, we can configure EIGRP also, we can configure static route also, we can configure RIP also. My requirement is 1.1.1 and 2.2 should be reachable, right? Lots of options are there and all the options should be very clear to you. Configuring a static route, configuring RIP, EIGRP और OSPF. OSPF सेम
आप
एरिया
कैसे
मल्टीपल एरिया।
कॉन्फ़िगर करोगे?
मैं तो सेम एरिया में करूँगा।
सारे के सारे?
हाँ।
ओके, ठीक है।
कैसे भी करो राउटिंग, दैट्स नॉट मैटर, राइट? एंड that is not connected to our VRF or MPLS concept. Okay? VRF or MPBGP or we can say L3 VPN just need reachability between P.
सर लास्ट टू लास्ट क्लास का मैंने राउटर 6 का कॉन्फ़िगरेशन मांगा था सर, इफ यू रिमेम्बर। आपने अभी तक भेजा नहीं। नहीं सर, ये लैब मेरा अभी तक हुआ नहीं है, सो आई जस्ट नीडेड इट।
Okay.